In the first part of this example, we have obtained the objective function z equal to 25x plus 21 and the constraints. And now our goal is to graph the system of inequalities and figure out our feasible solutions and see what the minimum cost is. So we always start with x is greater than or equal to 0, y is greater than or equal to 0. One last time, because this is the last example in this lesson, x is greater than or equal to 0 means all the points on the y-axis and to the right of the y-axis. While y is greater than or equal to 0 means all the points on the x-axis and above the x-axis. So right now, if there are solutions, they will be on the x-axis, on the y-axis, above the x-axis, and to the right of the y-axis. We continue. We have 2x plus y is greater than or equal to 12. We subtract 2x from both sides. Y is greater than or equal to negative 2x plus 12. We have a slope of negative 2 or negative 2 over 1 and a y-intercept of 0, 0, 12. Precision counts. Make sure that as you're doing this problem, you do use a graph paper. And if you plot the points carefully, if you figure out several points that lie on this line, it's easier to figure out the vertices without having to actually solve for them. We start at the y-intercept, and from there we go 2 units down, 1 to the right, 2 units down, 1 to the right, 2 units down, 1 to the right. Oh, that was bad. I only went 1 unit down, and so I want to go 2 units down, 1 to the right. And I continue this pattern until I hit the x-axis. We're almost there. 2 units down, 1 to the right. And finally, we have hit the x-axis. The x-intercept is 6, 0. I said 6, 0, and I plotted 7, 0. Isn't that something? Okay, let's graph our line. And so, right now, the region we're talking about is to the left, to the right of the y-axis, and above the right segment. When I graph, I said above, and then above the x-axis plus 1. We move on to our next inequality. 2x plus 9y is greater than or equal to 36. Subtract 2x from both sides. 9y is greater than or equal to negative 2x plus 36. Divide by 9 on both sides. Y is greater than or equal to negative 2 over 9x plus 4. Let's use a different color. The slope is negative 2/9. The y-intercept is 0, 4. Plot a point at 4, 0. And then go 2 units down and 9 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then another 2 units down, and then another 9 units to the right. So that's 16, 17, and 18. This is the 18, 0. To the best of our ability, let's draw best of my ability. It looks like the point of intersection, well, I'm not going to even venture to guess what that point of intersection is right now. Could go one down, about 4.5. Well, it's the best I can do. Let's graph above. And finally, let's take a look at our last inequality. We're now ready to graph the last inequality from the constraints. We have 2x plus 3y is greater than or equal to 24. Subtract 2x from both sides. 3y is greater than or equal to negative 2x plus 24. Divide on both sides by 3. And we have y is greater than or equal to negative 2 over 3x plus 8. Our y-intercept is 0, 8, and the slope is negative 2 over 3. Start by plotting the y-intercept, and then from there, go 2 units down, 3 to the right, 2 units down, and then 1, 2, 3 to the right, 2 units down, and 3 to the right, and once more, 2 units down, and 3 to the right. Graph the segment. Shade above. And we're done graphing all of our constraints. Next thing that we're going to do is you're going to want to see the region containing all the feasible solutions. And we're going to find all the vertices. So, start at 12, 0. Get to this point as coordinates 3, 6. So this vertex right here as coordinates 3, 6. Move on to the next vertex. The point right here, which has coordinates 9, 2, 9, 2, and finally, continue. The last vertex is the point 18, 0. Yes, this is an unbounded region. And from example 4, you know that we are lucky, but if we wanted to find the maximum, we couldn't, but we have to find a minimum. So we have our vertices are 0, 12, 3, 6, 9, 2, and 18, 0. Our objective is to minimize the cost, and so we have z is equal to 25x plus 20y. Let's start with the first point, 0, 12. Z is equal to 25 times 0 plus 20 times 12, which is 240. Next point is 3, 6. Z is equal to 25 times 3 plus 20 times 6. This is 75 plus 120, 195. Next, 9, 2. 9, 2. Z is equal to 25 times 9 plus 20 times 2. We have 225 plus 40, which is 265. And last, we have 18, 0. 18, 0. Z is equal to 25 times 18 plus 20 times 0, this is 450. So the minimum cost occurs when 3 bags of brand X are bought and 6 brands of brand Y. Here is the minimum cost. So finally, after about 15 minutes of work, we have figured out the answer. If the farming cooperative wants to minimize costs, they should buy 3 bags of brand X and 6 bags of brand Y. This is the end of the